So previously the focus was to detect shear waves in the inner core, because the detection of shear waves would be a direct evidence that the inner core was indeed solid, simply because shear waves can only propagate through solids. They don't propagate through liquids and plasma. So the simplest manifestation of the shear waves in the inner core is the so-called PKJKP wave, where J in the center stands for the shear waves in the solid inner core. And there were previous attempts where people observed what they thought were PKJKP waves, but there was no consensus in the community that basically those were the real observations of PKJKP waves. Instead of searching directly for PKJKP waves, we abandoned that approach, and we turned our attention to studying the similarity between weak signals. So basically what was a noise to some researchers before us became our signal. So we turned our attention to the records many hours after the origin time of the largest earthquakes in the so-called coda, or earthquake coda. Is a part similar in music. Coda refers to the last movement. So coda in seismology refers to these very noisy parts of a seismogram many hours after the origin time. And we discovered that basically the similarity between two weak signals in the coda is more powerful than the weak signals themselves. We turned our focus to a new paradigm that's called the correlation wave field. And basically by understanding what that correlation wave field is and how the features in the 2D representation that we call correlograms, how these features are formed, enabled us to make a discovery of J waves or shear waves in the inner core. By analyzing the features in the correlogram and how they formed, we were able to test different properties for the inner core in terms of its shear wave speed, the rigidity, and so on. And we were able to directly compare our numerical simulations with the observations, and we were able to then basically deduce the speed of shear waves in the inner core, and also some other properties about the inner core itself. This is the evidence that the inner core must be solid. The data also tells us something else about the inner core. It tells us something about the material property. So in other words, the inner core behaves more like a water saturated or a wet clay than the iron nickel alloy that is very rigid at those conditions.